Hello everyone, my name is Matt and welcome to this short video from Helyx on the Federated Marine Spatial Data Infrastructure Phase 3 D101 client demo. The video contains a brief introduction and run through of the approach before moving on to a quick demo of the client and wrapping up with some key findings. This is the third phase of the FMSDI pilot with an emphasis on both the land and maritime domains. This stage is centered around a fictional scenario located in the Arctic where a vessel has run aground, is lacking power, and there's a risk of oil spilling from the vessel. The sub-scenario for D101 client occurs after the initial grounding incident, once a search and rescue operation is underway, and is focused on the potential risk of an oil spill from the vessel. The approach taken was for an end user who is interested in the oil spill risk and wants to perform some initial analysis, as they do not have access to GIS software. A web-based client was developed using the popular JavaScript library Leaflet, as it is very accessible, easy to use, and can be extended using many plugins. The sub-scenario assumes the end user has no existing datasets available to them and have to source their own from external providers. They therefore need to be able to pull these datasets together in the client to perform some analysis. This helps the end user to make a best attempt at fulfilling a requirement within a short timescale rather than standing up dedicated IT. The client can also be deployed easily to a number of users. During this phase of the FMSDI pilot, the D101 client is connected to two servers from other participants, D103 and D104, which serve a number of datasets in OGC standards. The client is also connected to a number of other freely and readily available web services that are found online, serving data as WMS and WFS. Other datasets were also used that were not hosted as web services. These were downloaded and stored locally. The user inputs into the client. This sends queries to the various servers, which then send data back to the client. The client then processes the data and outputs the results directly into the client. Now, onto the client. We were able to ingest a range of data and also use several different base maps from different providers. This allows the end user to change a base map and focus on what is important for them. For example, as this phase is focused on both the land and maritime domains, an imagery base map can be very useful for certain scenarios. Shown here as a red line is the track of the vessel as it travelled eastwards before running into trouble. It then drifted south as indicated by the red dots. Also displayed on screen is some S100 data, indicating the maximum water depth, and has been styled within the client to show the different depths. The client has also ingested a number of WMS services with the air temperature shown here. Next, we move on to the oil spill, which was detected in remote sensing imagery and processed by the D104 server. The analyst is interested in this and wishes to see where it might be affected in the future. The analyst has been given some information about the oil spill and some parameters on how it may spread over time. They can choose one of the preset options to generate a buffer of the oil spill. After some time taking to process, the client returns several buffers around the oil spill. Shown here are 5 buffers representing the potential spread over the next 5 timeframes after the event. Finally, the analyst wants to know what port the vessel may be taken back to. Using some open source research, they decide that Nome is the most likely port that Discovery be towed back to. They can draw a route within the client, and both maritime and terrestrial datasets will be returned back to the user. So to summarize some of the key findings, the client was able to ingest, process, and visualize a range of maritime and terrestrial data sources. OGC APIs permit spatial filters which help to limit data volumes in the client. It also allows IHO data and OGC APIs and standards to be used by a wider audience via a simple web client. Client-side processing is possible, although it can struggle with complex shapes or large datasets. There are, however, numerous approaches that could help with this in the future. Modelling oil spills is obviously a very complex topic, and there is scope to use scientific models in future work rather than some simple geoprocessing, providing the right data over the area of interest is available. Finally, one issue that presented itself was that there are occasionally discrepancies between the various land and maritime datasets. The coastal zone is prone to most change, so depending on when data was captured or processed, there can be some differences between these datasets. To help minimize these effects, it is important that data is captured to agreed standards, with accuracy and relevant metadata being key to help the end user.